Scholars, today we're going to go over a couple of problems that involve operating with fractions. So let's take a look. Example number 1. What is 2/3 of 60? Okay, so we can actually solve this in a couple of different ways. So the first way is we can rewrite this sentence as an equation, right? As an algebraic equation. So what is means what is it? X equals what? 2/3 of means multiplication 60. So it's asking us to multiply 60 by 2/3. We can do this with a calculator, that's fine, or right, we could say 2/3 of 60 is the same thing as, right, is the same thing as 2/3 times 60 over 1, right? Okay. And here I can start canceling, right? So I know that 60 goes into 3 20 times, and I end up with 2 times 20 is 40. So our answer is x equals 40. This is one way of doing this problem. Okay, another way we can sort of reason through it. Okay, well, 60 is the whole amount. This is the whole amount that we're talking about, right? So if I were to ask what is 3/3 of 60, the answer would be it's just 60, right? Because 3/3 is just 1. What is 1 of an apple pie is an apple pie. Okay, so if I know that 3/3 of 60 is 60, I can reason then that 1/3 of 60 must be 20, right? Okay, well, if one of these thirds of 60 is 20, then I can reason that 2 of these thirds of 60 is 2 times 20, right? It's got to equal 2 of those 20s, otherwise known as 40. Okay, so we can reason about this in a couple different ways. Now, this is a sort of simple example. However, we could use that to solve more complicated word problems. So for example, if 2/3 of a group of 60 students don't know who Billy Joel is, then how many students know who Billy Joel is? Well, we already know from our last question that 2/3 of a group of 60 students, this means that 40 students don't know who Billy Joel is. Well, and if there are 60 total students, then 60 is the total, right? Minus the 40 who know, or the 40 who don't know, will leave us with the 20, right, who do know who Billy Joel is. Who know who Billy Joel is. So that's one way of getting to this answer. Another way of getting to the answer is, I know that if 2/3 of 60 students don't know, then 1/3 of 60 do know. And 1/3 of 60, again, is 20. So this is going to get to your same answer. Example number 2. You eat 2/5 of a cake, and then your dog eats 2/3 of what you didn't eat, what you left over. What fraction of the cake is left? Okay, so this one is as 2 steps happening, right? You eat some cake, then the dog eats some cake. So let's start with you. Here you eat 2/5 of a cake. All right, here's our cake. Here it is divided into fifths, you know, more or less even fifths. Okay, close enough. Okay, you eat 2/5 of them. So let's color in what you eat in red. So those things are gone. So what's left over? Well, what's left over is 3/5 of the cake. So when you eat 2/5 of the cake, 3/5 is left. Okay, so this part is gone. What's in red is gone, and what's left is in blue. So this is all gone in your stomach. Okay, then what happens? Your dog comes in and eats 2/3 of what you didn't eat. Okay, so now the dog is coming in. The dog is eating 2/3 of this area in blue, right? We could say the dog is eating 2/3 of the 3/5 that is left, right? That's another way of representing what the dog is eating. So the dog is eating this, right? So in our picture, well, it's nice. This is already in three pieces, right? So 2/3 of 3 pieces is 2 pieces. So the dog comes in and eats, right? The dog comes in and eats 2 out of those 3 pieces, right? So this was you, this is the dog, And now what's left over? Well, what's left over is nothing more than this piece of pie, which is 1/5. So 1/5 of the cake is left over after you eat some and the dog eats some. So let's see if that matches up to our sort of algebraic expression here. So again, this is what the dog ate. So the dog ate 2/3 of these 3/5. In other words, the dog ate, you could multiply it out and reduce it, or you can just cancel the 3, same on the top and the bottom, right? So the dog ate 2/5 of what was left over, right? And that's exactly what we found, right? We had the dog eating 1/5 and 2/5, right? So you eat 2/5. So you have a whole cake. You eat 2/5. The dog eats 2/5. And what do you have left over is nothing more than 1/5, which is exactly what we found in our picture. Okay, let's take a look at one more example. Example number 3. Write 2/3 in a few different ways. Okay, so this is an open-ended question. One way I could write 2/3, I could write it as 4/6, right? Using proportional reasoning. I could write it even as 6/9. Could write it as 20/30. You notice all of these, right? 4/6 is nothing more than 2 times 2 over 2 times 3. 6/9 is 3 times 2 over 3 times 3. 20/30 is 10 times 2 over 10 times 3, right? And you'll notice that all of these are nothing more than a hidden 2/3, right? Where the top and the bottom, the numerator and denominator, are just being multiplied by the same number, right? In this case, it's being multiplied each by 2, or by 3, or by 10, or in fact, by any old number, right? This is the key to proportional relationships. So another way that I could write 2/3 is I could write it as 2 times x over 3 times x, where x is any number that's not equal to 0, right? Because we can never divide by 0. But, for example, 2 times 7 is 14, 3 times 7 is 21, and in fact, 14 over 21 does equal 2/3 as well, right? These are all possible examples, right? And is there any other way I could write 2/3? Sure, I could write 2/3 as 2 times 1/3. That's allowed, right? I could certainly do that. I could even write it as 1/3 times 2, right, using the commutative property of multiplication. So there's a bunch of different ways. Before we go, let me call your attention to one very common mistake that students make sometimes. A common mistake is to say, I want to write 2/3 in a different way. So you know what I'm going to do? I'm just going to add x on the top and the bottom. So 2 plus x over 3 plus x, well, it's of course that has got to equal 2/3 because x's and x's, right? I can just take the x's, I can cancel them out, right? So this has got to be true, right? No, 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 no. This is not true. This is a mistake, a common mistake. Okay? And in order to sort of make sense of why this would be a common mistake, let's try it with a number. Okay? This is a really good strategy. If you're wondering if a pattern, right, if a formula holds, plug in a number and see what happens. Okay, so if this was true, I could say that 2 plus 1, right, over 3 plus 1 would equal to 2/3, right? It would have to be equal to 2/3. Just I let x equal to 1, right? That's all I'm doing here. Well, 2 plus 1 is 3. So here, let's keep writing over here. 2 plus 1 is 3, and 3 plus 1 is 4. So the question is 3/4 equal to 2/3? And the answer is no, they are not equal, right? I would much rather have 3/4 of a dollar than 2/3 of a dollar, right? You can even, if you just want to go back to your pie chart, right? Here's 3/4. 3/4 is 1, 2, and 3, right? And here's 2/3, right? We can also say maybe this is like how we divide up into thirds, roughly. Something like that, right? And so 2/3 is maybe this part and this part, right? But there is a piece, right? There is a piece right here where that is part of the 3/4 that is not part of the 2/3, okay? Or you can plug them in the calculator. 3/4, you're going to get 0.75. 2/3, you're going to get 0.666, something like 0.67. So this is clearly a larger number. So since it doesn't work with this one particular example, it means that in general, this is not how proportions work. They don't work additively, right? You could have said, it does work to say that 2 times x over 3 times x does equal 2/3, right? We saw that earlier. That's okay. Those we can cancel because they're related multiplicatively. But they're not, you can't cancel parts of numerators and denominators in this manner, right? So this idea of canceling out the x's is a no, 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 no. No, don't do it. Okay, have a great week.